This course will teach you essential Arduino and programming skills through a series of fun mini projects of increasing complexity. The core theme of these mini projects is an Arduino-powered car. Each mini project allows you to explore interesting hardware and programming topics. For example, in one project, you'll explore vehicle safety using an ultrasonic distance sensor. And in another project, you'll learn how to control the Arduino car with your smartphone. You learn how to program motors, take input from sensors to implement automation features, and explore various options to control your car. In this lecture, I'll talk about the following. First, I'll talk about the learning objectives of the course. Next, I'll talk about the hardware and software specifications and requirements. And third and last, I'll talk about the organization of the course. Before we continue though, please know that this is not an introductory course. In designing this course, I assume that you are already familiar with the Arduino. You should know how to wire up simple circuits on a breadboard and upload a sketch to your Arduino. You should also be able to read and understand simple Arduino code, install external libraries to the Arduino desktop IDE, and know how to fix simple code bugs and wiring errors. You can also read technical documentation and have the patience to learn from documentation and code samples and apply new knowledge to your projects. If you don't feel confident about the skills I described, I recommend taking a step back, completing an introductory course, such as my course Arduino Step-by-Step Getting Started, and then returning with this course. Next, let's look at the course learning objectives. A course like this allows you to learn new soft and hard skills. What you will ultimately learn depends on many factors that are out of my control. Your existing knowledge, aspirations, goals, and motivations greatly influence what you learn from this course. With the term soft skills, I mean the skills that help you to troubleshoot and solve problems, analyze requirements, find high-quality, relevant information, and design an engineering solution to a problem that considers technical and non-technical requirements. As soft skills, I also classify the ability of a person to persevere through complex problems and self-guide without constant reliance on external support and direction. I haven't designed this course to teach you these soft skills specifically. However, you will improve on all the soft skills areas that I mentioned through your exposure to technical projects with verifiable objectives. In this course, even though I've made all relevant technical decisions and have solved all related problems as part of the course design, you will witness my decision-making process and to a certain extent participate in the development process. You will gain the most by following me in each mini project where you will inevitably have to struggle with and then overcome unexpected bumps along the road. Now let's look at the hard technical skills you learn in this course. In this course, you learn to use an Arduino Uno along with various peripherals such as 1 or 2 DC motors with the help of a motor controller module, an analog joystick, an infrared sensor that can receive encoded commands from an infrared remote control, an ultrasonic distance sensor, a buzzer, and 2 radio frequency communications modules, a Bluetooth BLE or low energy module for near field connectivity, and an ESP01S Wi-Fi module for internet connectivity. You will also learn how to power your Arduino motor project with 1 or 2 batteries to separate the Arduino and motor sub-circuits. In addition to the hardware skills, you'll learn several software hard skills, such as how to program car functions with the infrared remote control, how to use Bluetooth low energy along with your smartphone and the Arduino Blue library to control the Arduino car, how to use the ESP01S Wi-Fi module with the Blink cloud platform and your smartphone to also control the Arduino car and its peripherals, how to compensate for tiny differences between the motors that affect the driving qualities of the car, how to use the distance sensor to prevent a crash, and 2 different ways to control the speed of the DC motors. These are the technical learning objectives of this course. Now let's have a look at this course's hardware specifications and requirements. Basically, what is the hardware that you'll need? Almost all of the hardware used in this course is conveniently part of the 3-in-1 IoT Smart Car Learning Kit for Arduino by SunFounder. This kit contains the car chassis and motors, an Arduino Uno clone board, sensors, the ultrasonic Wi-Fi and infrared modules, wires, breadboards, and a 9-volt battery and clip. A few items are not in the kit: a Bluetooth BLE module, a switch, and a couple of meters of 4-wire flexible cable for the joystick. You can purchase these items from SunFounder, which is convenient and price competitive, but you can also source all of those components from many online and offline retailers. But before you purchase any hardware, please take a few minutes to watch the following lecture, Hardware and Kit Overview, where I discuss all hardware components needed in this course. In terms of desktop software, you will need the Arduino Desktop IDE and a browser. I assume that you already know how to use the Arduino Desktop IDE, and if not, I recommend that you complete at least the first half of my course, Arduino Step-by-Step Getting Started. You'll also need a free account on blink.io, an Internet of Things platform. I'll show you how to create a project on Blink, but I will not cover the more intricate details. If you are interested in the details of the Blink platform, you can look at my course, Arduino Mobile Development with Blink. All the Arduino code I show in the various lectures is available to download from the course GitHub repository. This will save you a lot of typing. Now let's have a look at the course organization. The course has 7 sections that take you through the 4 mini projects and other supporting and learning content. In the first section, Getting to Know the Hardware, you learn how to use each component in isolation. For example, you learn how to rotate a DC motor and use the Wi-Fi module to connect to the internet. By the end of this section, you'll know how to use a joystick, the motors and the motor driver, the infrared and ultrasonic sensors, and the Bluetooth BLE and Wi-Fi communications modules. In the next section, you'll assemble the core parts of the Arduino car, which consist of the chassis, the motors, and the Arduino Uno board. In the mini projects that follow, you'll add various modules to try out different configurations. You'll work on variants of the Arduino car in the 4 successive sections. You'll start with an Arduino car that you can control with a simple analog joystick connected via cable. Then you'll retrofit the car with an infrared wireless remote control and receiver. In the last 2 mini projects, you learn how to use your smartphone as a remote controller and communicate with the car via Bluetooth BLE and Wi-Fi. And in the last section, you learn how to improve various aspects of the car's performance. For example, you learn how to use the ultrasonic distance sensor to prevent collisions, how to compensate for slight speed differences between the 2 motors that make the car drive in a curve rather than in a straight line, and how to control the speed of the car. And with this, I hope that you now have a clear view of what's ahead. In the following lecture, I'll talk about the hardware that you'll use in the course. In this lecture, we'll have a look inside the 3-in-1 IoT Smart Car and Learning Kit for Arduino from SunFounder. This kit contains all of the components that we'll need for the various experiments that make up this course. And I'm going to highlight those components. I'm not going to show you, of course, how they work. There are dedicated lectures for each of the components that we need later on in this course, where I'll show you how to use those components individually and then how they work as a system as part of this experimental car that we are building and the various experiments that will run on this car. Of course, it is possible to construct the car and go through all of the experiments in this course without having purchased this specific kit from some founder. You can relatively easily source all the parts that you need from various online sources such as eBay or Amazon. It's just that the kit makes it easy to get everything you need with one single purchase. But once you know what components you need, then you can decide for yourself whether you'd like to go ahead and get them as part of a kit or get them individually from a variety of online sources. So let's get started. Once you open up the box, you'll find the wheels for the car on the side. I'll put those out for the time being. And you've got the kit, which contains all of the electronic components like this, and there's a few tools in there as well. And in the bottom of the box, you'll find the chassis for our car. It looks like this. So the chassis is protected with adhesive paper, which you can remove if you want. I decided to actually keep the paper on because it is paper, which means it allows you to write little markings like that, so you can easily figure out which side is A and B as you're following with the instructions. So totally up to you. I'm going to put this aside now and have a look inside the plastic box. The underside of the cover has a list of all the components that are included. It's a quick reference guide. It shows you everything that's in the box so that you know what's in it without having to dig through it looking for particular components. So one thing to remember here is before I go any further is that obviously I've been playing with this kit for a while now, so all the components you just see did actually come with this kit, but they were a lot more tidy when the kit arrived. Now they look like a total mess because I've been playing with them, and just keep that in mind. When I received this kit for the first time, things in it were actually nicely organized. Everything pretty much was in bags to protect them. For example, the ESP8266 or ESP01 board, which we'll be using for Wi-Fi connectivity, this came protected in an anti-static bag, which of course I got it out of in order to be able to use it. But pretty much all of the sensitive components will be protected in a plastic anti-static bag. So keep that in mind. So I'm going to show you the components that we'll be using for our car experiments so that you know what's coming up, and you can then decide which of those components you'd like to purchase separately. Starting from the very top, I've got the ESP8266. You can also find this device titled or named as ESP01. It's essentially a microcontroller board with just a handful of input-output pins, and we'll be using this microcontroller as a serial Wi-Fi module. The microcontroller is the ESP8266, and it already has the Wi-Fi required firmware burned on it, so we're not going to have to do anything to it other than just start changing some of its settings in order to use it with our sketches. And because, as you can see here on the underside, its pin configuration is not really compatible for our breadboard. It comes in a 2x4 pin configuration. We'll be using this adapter here. We can connect the ESP01 onto the adapter like this, and that breaks out the 2x4 pin configuration into a breadboard compatible pin configuration. So then we'll be able to use our breadboard. There's also a mini breadboard inside the box, but I'll show you with this longer breadboard what it looks like. We'll be able to plug in the adapter like this, and now we'll be able to connect the pins to the Arduino Uno microcontroller easily. So that's an important part of our course. We'll be using this adapter and Wi-Fi module in one of our experiments. Put it aside. Another component that we'll be using is this infrared sensor. We'll use this infrared sensor alongside with the infrared remote control to wirelessly control movement on our Arduino car. So these two go there. We're not going to be using the sensor. We'll be using one of those LEDs just as a indicator of the functions that we are sending to the car. So for example, every time we press a button on the remote control to verify that the command has been received, we'll have one of these LEDs flashing. You just need one of those LEDs. These plastic bits here are used with the chassis to help us mount the DC motors that are inside the box. So make sure you've got 4 of these as well, 2 for each motor. There's some Velcro tape here. This allows us to stick the battery onto the chassis, the battery actually and the mini breadboard onto the chassis. I've already attached one of those Velcro tapes onto the underside of the chassis. The other part is here on the 9-volt battery, which is included with the kit. So batteries are included. You'll be able to use this tape to safely attach, in this case, a battery to the chassis. It goes there. I'll put this back in because I'll need it later. All right, we're not going to need anything else from this tray for the purposes of this course, so I'll put this aside. Of course, there is the microcontroller board itself. This is an Arduino Uno compatible board. This is actually well made for a compatible board, so you can use that. In my case, I'll be using the genuine Arduino Uno board like this, but they're fully compatible, so it's totally up to you which one you'd like to use. There is the mini breadboard that I mentioned. We'll use this mini breadboard attached onto probably the front. This is the front. We'll use it on the front of the car chassis because that will allow us to assemble experiment components easily in different configurations, then remove them and make room for the next experiment. And again, I'll use a bit of Velcro to attach it onto the car, or alternatively, you can just remove the backing of this adhesive tape and use that to securely attach the breadboard onto the chassis. It's up to you. I'll probably do that myself. Then we have the 2 DC motors with the gear system as well. So the gear system that is enclosed in those yellow cases allow us to provide a bit more fine movement as it's coming out of the motor, because the motor itself would be spinning quite fast naturally. So you can use reduction gears in order to increase the torque on the wheels and reduce the speed consecutively. In the wheels, you don't need to use screws. The wheels just securely attach onto the shaft here of the motor like this, just by pushing them in. There's indentations to make sure that the wheels are not spinning independently of the motor. So you can just gently push that in, and then you've got your wheel attached to the motor. Okay, so we've got 2 of those, but the motors cannot operate without a motor controller. So we'll be using this motor controller. It's a standard L298N. I have a detailed set of lectures on how to use this motor controller in my other course, Arduino Step-by-Step Getting Serious. So I'm still going to show you how to use this motor controller with the 2 DC motors in this course, but I'm not going to go into the fine details. You can look up those details in the dedicated lectures in Arduino Step-by-Step Getting Serious, and do that just to save a little bit of time in this course. All right, there's lots of jumper wires like this in different configurations. So male, both sides, it's male and female. So you can use the jumper wires as needed with the breadboard. A few other things that we're not going to be using are spacers. Yes, spacers and screws. So these are very well labeled. So we'll be able to use those labels to make reference to which of those spacers you need to use when the time comes to assemble the chassis. There's a second ESP01 or ESP8266 microcontroller. There's not a second adapter. There's only one adapter, but there are two of those boards. There is the caster wheel for the chassis. Going to go to the front. There's a joystick. So this joystick is going to be used in one of the experiments in this course. We'll be able to use it to control the movement of the robot using a wired example instead of wireless. It's also got a button function, which we won't be using. We'll just be using the 4 directions. There is a ultrasonic distance sensor. We'll use this sensor here to introduce a safety feature on our car. So we'll get our car to be able to detect obstacles and then stop before it crashes onto an obstacle. Assorted resistors, we'll be using a couple of those. There's tools included. Phillips screwdriver set. And there are a few nuts as well. Longer screws, we'll be using those to mount the DC motors onto the chassis. And that's about it. There's a few other bits and pieces here that we won't be using in this course, but I'll be using some of those components in another course that I'm also working on it, just to take advantage of all the capabilities, all the experiments that this kit allows us to construct. Okay, and that's it with the kit and the hardware for this course. To complete this course and achieve your learning objectives, you'll need to put aside time and make a significant effort. In this lecture, we'll look at a few things you can do so that the time that you spend on this course is both effective and enjoyable. In this course, I use an Arduino Uno and various modules that come with the SunFounder 3-in-1 kit for Arduino. You can see the complete listing of the hardware components in the course parts list at texplore/Arduino Car. If you have not already watched my dedicated lecture on the hardware components for this course, please do so before you begin work on the course. You don't have to use the same hardware that I used, and you don't need to purchase the SunFounder kit. While it is convenient, you can source all of the components that you'll need from many other online sellers, such as on Amazon, eBay, or AliExpress, and of course your local electronics DIY store. Using any Arduino Uno compatible board is okay if it uses the same form factor as the genuine Arduino Uno. This way, your Arduino board will fit well with the mounting holes of the car chassis. It is also okay to use an Arduino Mega 2560. You can mount an Arduino Mega 2560 on the car chassis, though one side will extend over one of the wheels. The Mega will give you many more digital pins to grow your Arduino car with additional hardware if you wish. The SunFounder 3-in-1 Arduino kit contains all the necessary parts for this course except for the Bluetooth BLE module. You can find the Bluetooth module on the SunFounder website or of course at your preferred retailer. Again, you can find a complete listing of the hardware for this course on our website at texplore/Arduino Car. This course has a GitHub repository that contains all code and schematics. You can copy this code to save time and reduce the risk of bugs. You can also print the schematics and annotate them with your modifications. And you can see the URL for the repository in this slide. You can download the entire repository to your computer or work with one file at a time, like one schematic or one sketch. The GitHub repository is easy to navigate. Each file starts with a numerical ID of a lecture. You can use these numbers to find the sketch and schematic for each lecture quickly. Now let's talk about time. Learning anything worthwhile takes time. Plan for your learning and dedicate the necessary time to your schedule. Be in control of your learning through planning. I have designed this course for people that are already familiar with Arduino, wiring and programming. You can complete the course out of order if you feel comfortable with the individual hardware components. If you have gaps in your knowledge, you should complete the course in a linear manner, one lecture at a time from start to finish. The projects are relatively independent. However, I often refer to previous lectures I assume you should have already completed. You should plan to complete each project in one sitting. Projects 3 and 4 do take longer to complete because they involve relatively more complicated software and hardware components. Most people will be able to complete projects 1 and 2 within 1 hour and projects 3 and 4 within 2 hours for each project. Do not mark a lecture as completed until you have achieved its practical objectives and have fully understood it. For example, if the practical objective of a lecture is to get the car to move forward, backward, left and right with the joystick, don't mark it as completed until your car can do this and you have understood how the Arduino code works. If you proceed through the course without completing the practical and learning objectives of each lecture, you will strike an obstacle that you will be unable to overcome later and you'll have to backtrack. Okay, I hope that you are ready to begin. In the next section, you learn about the individual components that you'll use in the Arduino Car mini projects. Hi, and welcome to a new section in this course. In this section, we are going to focus on the individual components that make up this Arduino car. Just want to demonstrate how you can use each one of the components individually. So for example, we'll have a look at the motor controller that you see right here and the motors and how you can use Arduino sketches to control the motion. A couple of other things I can show you here is the infrared sensor. I'll show you how you can use that alongside the infrared remote control to control the car. And I just happen to also have a joystick here. So I'm going to show you in a separate lecture in this course how to use the joystick. But I wanted to kickstart this section with just a look at the chassis that is going to hold together all of these components. So essentially, it's the central component of our car. As I said, the component that we use to mount all other components together. And it's just one thing. It's just this acrylic black plastic piece that you see here. I've got the other components mounted on. In this example, you see that I have already mounted several other components on the chassis. I'm going to show you how to do the actual assembly later on in this course, but I just wanted to show you a view of what the chassis looks like. And in this particular example, the components that you see mounted, some of those components do come from the 3-in-1 kit from Sunfounder, but I've got a couple of other things that don't. So for example, flip this car over and you can see that down from the bottom view, there's the two DC motors plus the 9-volt battery that powers the motors plus the Arduino. And I've got the caster here in the front to give us direction and the two wheels that are attached directly to the motors. And that's what's on the underside. On the top side, you'll see a couple of interesting things. There's the motor controller. Again, this is part of the kit. The Arduino Uno, this is a compatible board that is also part of the kit, and that's mounted on top of plastic spaces like this. Around the back, I've got a mini breadboard. In this case, I used a cable tie to secure the breadboard onto the chassis. And there is a the photoresist. I think I've taken it out. Yeah, so there's just an LED here. Apart from these components that ship with the 3-in-1 kit, I thought that it would be useful to have posts like this, or like adapters, essentially, or holders like this that I designed in Tinkercad and printed on my 3D printer. And what this particular post allows me to do is to mount the remote control wire. You can see, to give you a closer look. So here's the cable that at the end, the other end, I have connected the joystick. In one of the examples later in this course, I'll show you how you can use the joystick to control the car in a wired configuration. There's also wireless options, but in this case, I'm going to go with wired. And in my first couple of experiments, of course, the cable was long enough to be dragging on the floor. And I decided that it was not a good idea having the cable dragging on the floor. So I needed to lift it up a little so that it sits up higher, and I can then control it without the danger of the cable being tangled in the wheels. So that's one application. Then another application, when I was prototyping the infrared receiver, had to do with the location of the infrared receiver. So in this example, I've got the infrared receiver connected to the Arduino on the breadboard. And of course, its optimal viewpoint location where the remote control will be positioned will be behind. So this position will be behind the car. So if you happen to be on the front side of the car, then the receiver won't be able to receive the infrared signals unless they happen to bounce off another surface, and then they can be seen by the receiver. And I thought that probably a better location for this receiver would be a bit higher up. So I printed a second adapter, second post with this little component up here, top here. So I reasoned that if I can position the receiver up higher, say around here, I'll be able to control the car from a much wider range of angles around the car. And the way that I did that was to just make use of the same 3D printed part. I've got mounting holes up along the post, so I can use things like cable ties to secure the cable against it so it doesn't move around, but also to secure components like this. Just plug it on the very top mounting hole, and then any other components such as an infrared receiver can go up the top. So all of that comes from the benefit of using a chassis like this, which has pre-drilled mounting holes that you can use to mount the various components, whether those come with the Sunfounder kit, or you can just add your own components and your own design and enhance the original design. So chassis like that, I find them very useful. And I just wanted to give you one more example. So this is another example of a similar concept here. This is from one of my other Arduino robot courses. This is a self-driving robot. And I used a similar concept type of chassis. It's a little bit more involved because it has two plastic plates. You connect them with those spaces, and there's a little bit of space in between that you can use for things like a battery pack, for example. In this case, I decided to put it on the top, but I could have used a different kind of battery and mounted in the middle to allow more space on the top, easier to access for me to tinker with and prototype. So again, similar concept. There's lots of openings that you can use to mount spaces, mount components. In this case, to secure the battery pack on the chassis, I just used screws with a rubber band, and that's enough. You can see here in the front, I've got a servo motor that allows me to control the direction where the ultrasonic sensor is pointing to, and that is directly secured on the chassis with simple spacers. There's nothing fancy here. And on the underside, in this case, in this example, instead of using DC motors, I'm using continuous rotation servo motors because I wanted to have a bit more control, fine control of the movement of the motors. And a continuous rotation servo motor can do that a little bit better as opposed to a regular DC motor. So you can control the angle of the turn of the wheel much easier. All right, so that's a little comparison between different chassis. Of course, if you have the one that came with Sunfounder, you can use that, or otherwise you can substitute with something similar. Now, just the last thing that I wanted to show you here before we move on is the provision for the Arduino Uno. So there are mounting holes here on the chassis. There's 4 mounting holes. And there's another one right here. I'm going to show you this in more detail when we do the assembly, that supports a Arduino Uno or original or compatible board. And in this case, you can see the Sunfounder Arduino Uno compatible device. It comes with the 3-in-1 Sunfounder kit. But of course, you can use any other Arduino compatible device. Here's my genuine Arduino Uno. It fits perfectly. I was also experimenting with other Arduino options, such as the Arduino Mega 2560. Obviously, the Arduino Mega 2560 has got an Arduino Uno compatible side in terms of the layout of the pins. So that left side is compatible, and it's got an extended side on the right side. So I was just looking around, and this can actually work almost as a Arduino Uno would on this particular kit. The 2 mounting holes on the left side match perfectly with the Arduino Uno, and you also have another 2 on the other side, right here and here, and those also fit perfectly. So an Arduino Mega 2560 will also work, and you're going to have the extended part on the right side, which clears the wheel, so there's not going to be any interference. So if you happen to have an Arduino Mega 2560, that will also work with this kit, and will give you a few additional pins to work with. Okay, so that's it with this lecture. Just wanted to show you what the chassis looks like, and what are some of the things that you can do with it. I'm going to show you how to assemble the kit later on in this course. In the next lecture, I'm going to quickly review your microcontroller options, and then we're going to move on to have a look at the individual components, such as a joystick, the DC motor controller, and the motors, the sensors, etc. In this lecture, I'd like to take a couple of minutes to talk about the microcontroller that will be controlling this Arduino Car project. So the Sunfounder 3-in-1 kit comes with an Arduino Uno compatible board, like this one here. So this is a fully compatible Arduino Uno, and of course you can use it, and it will match perfectly the provisions here on the chassis. It should go this way, so that you can mount this Arduino Uno compatible device on your car. In addition to that, of course, you can always use a genuine Arduino Uno. The mounting holes are exactly the same, and this is actually the board that I will be using in this project, and you'll be seeing later on in the videos that follow. So this is the board that I'll be using. Now, in the last lecture, I also mentioned that you can use an Arduino Mega. Even though the board is longer, the mounting holes that are important are these right here, which are compatible with the Arduino Uno board. And I've cleaned up the chassis a little bit from its components so you can see how it fits nicely on the board. So I'm just going to align the mounting holes onto the spacers, and you can see that there is a perfect match, and there is clearance between the board and the wheel, so those two will not interfere. So what I like about this option is that there are a lot more pins that will allow you to explore other options, other experiments with this same car configuration on the same chassis. In one of the experiments in particular, I found that we were kind of pushing the limits of the Arduino Uno in terms of its RAM memory capacity. And with an Arduino Mega, you can go a little bit further in that regards. You can have more complex projects that depend on more complex sketches running on your Arduino. So these are the main options. Now, in addition, of course, there's more you can do. If you are feeling adventurous and you wanted to try other Arduino boards as well, for example, the Arduino Zero, like this one here, this is an M0 Pro, or you can find it today as a modern Arduino Zero board. It has the same form factor as the Arduino Uno, so it will match with the provision for the mounting holes on the chassis, but this gives you more computational power, more capabilities compared to the Arduino Uno. So you can experiment with running a robot, an Arduino robot, on a more advanced board, such as the Arduino Zero. And speaking about modern boards, here's another example. This one here is the Arduino MKR Wi-Fi 1010. This is one of the most current modern boards in the Arduino lineup, and you could use one of these with your Arduino robot, with your Arduino car. The problem here is that the mounting holes are not going to match, and then you will have to improvise other ways to match the chassis with the board. For example, one thing that you could do would be to design an adapter on a CAD drawing program such as Tinkercad and then print that adapter on your 3D printer. This is not an adapter for this particular use, but it's just an example of a design that I made that allow me to build on the chassis in order to accommodate additional needs that the designer of the chassis did not anticipate. And you could do the same thing for a board like this. Now, one thing to remember if you are thinking of doing something like this for this course is that all the sketches that I have prepared to show you work on an Arduino Uno, and in particular on a Arduino device with the Atmega 328P processor or microcontroller on it. The sketches for the Arduino Uno R3 will also be fully compatible with a microcontroller such as the Atmega 2560 that you'll find on the larger Arduino Uno variant, the Arduino Mega. So you can be sure that any sketches that run on the Arduino Uno will also run perfectly well without any modifications on the Arduino Mega. But if you choose to go for something like this, like the Arduino Zero or the Arduino NKR, then you may need to make some modifications to some, at least, of the code in the sketches. For example, the code that works with the Wi-Fi adapter on the Arduino MKR is going to be different to the code that utilizes Wi-Fi breakout adapted capabilities that will be looking at the Arduino Uno option. So we do have an experiment later on where we use an ESP8266 microcontroller to provide us with Wi-Fi capabilities, and that code will not work with the NKR 1010. You'll have to modify that. Another option that you have, I don't have, unfortunately, the board to show you, the physical board, but you can have a look at it on the Arduino website, is making use of the modern Arduino Nano microcontroller, which comes in a small form factor. It's about the same size as the Arduino MKR. But the advantage of that board is that it uses a microcontroller that is essentially the same as the one on the Arduino Uno. So you'll be able to use the Arduino Nano without having to modify any of the sketches. Still, though, you will have to figure out how to mount that smaller microcontroller on the chassis. You can, as I said, use an adapter, design one on Tinkercad. I think that's going to be a pretty good exercise for you. Or another thing that you can do is you can just drill holes as you see fit, as you need on the existing chassis. It's just the thin plastic here. You can easily drill through it and add more mounting holes as needed for your project modifications going forward. Okay, and having said all that, we can now continue with the next few lectures in this section, where we'll have a look at the individual components that make up this project. In this lecture, we are going to have a look at the first of the components that make up our Arduino remote control car, which is the joystick. In the next few lectures in the same section, I'll show you how to use the motor with its motor driver, the infrared sensor, the ultrasonic sensor, the Bluetooth HC06 module, and the ESP01 as Wi-Fi module. But before we begin, just wanted to point out a couple of things. The first thing is that in this lecture and some of the lectures that follow up, I'm borrowing content from one or more of my other Arduino courses. In this particular case, for the joystick, I'm borrowing content from Arduino Step-by-Step Getting Serious. Towards the end of this course, I've got a section dedicated to joystick with a couple of examples. In this lecture, I'm going to borrow from the first of these examples, which is just a simple application of the joystick. I'll show you how to wire up the joystick to your Arduino and then how to utilize a simple sketch to extract data from the joystick. The second thing to notice is that in this example, just like in some of the examples that are coming up in following lectures for the other bits of hardware that we'll be using, I'm using specific pins to connect the particular component, in this case the joystick, to the Arduino. It is not necessary to use the same pins later on in the course when we integrate all of the components into a single system. In this sketch, for example, I'm using pins A0, A1, and A2 for the X, Y pins and the button pin. In fact, in the actual system later on, when we integrate the components together on the chassis to create an Arduino remote controlled car, I may choose to use other pins because there may be conflicts with other components. So keep that in mind. We start simple with the most simple possible configuration in order to learn how to use a particular component, and then we'll use that knowledge and adapt it to make it work once our circuits start to become a little bit more complicated. If you have enrolled to Arduino Step-by-Step Getting Serious, then you can have a look at the joystick example that I'm about to show you here in section 44. If you haven't joined us in Arduino Step-by-Step Getting Serious, you can still get the schematic and the sketch that I'm going to demonstrate by going to the GitHub repository for this course, which is free for everyone to visit, and you can copy the sketches, no problem at all. So, having said all that, the first thing that I'm going to do is to copy the sketch from the repository into my Arduino IDE, and to do that I'm going to go to the raw view, then select all, copy, and paste this content in here, and I'll save it on my computer. All right. Done with this bit. So let's continue now. I'm going to go over to my bench, do the wiring, and then upload the sketch and see what the output is from the joystick onto the serial monitor. So let's go ahead and do the wiring now. Here's the joystick. It looks like that. It's got the joystick up the top, which also contains a button, so you can push it down and that engages a button. You've got ground and the 5-volt positive for power. Then there's the X dimension and the Y dimension pins. And finally, the last pin, SW, identifies button press, or we can use it to identify a button press. So I'm going to keep the cap off for the time being so that it's easier to access the pins and you can see them easier through the camera. And I'm going to use this schematic diagram from Arduino Step-by-Step Getting Serious. This is lecture 635 in that course. So the way that we are going to do the connections is that GND is going to go to GND on the Arduino. 5 volts positive will go to 5 volts. VRX will go to analog pin 0, VRY to analog pin 1, and we'll identify the button presses via analog pin 2, even though we'll be using this as a digital pin on and off. All right, so connections are done. Let's go and upload the sketch. Now let's turn our attention to the sketch. So in the beginning of this lecture, I copied the sketch from the Arduino Step-by-Step Getting Serious GitHub repository, and I haven't made any changes to the sketch, but I am about to make one small change. You can see here in line 49, I've got the LED pin set to 7, so that when we press the button that's part of the joystick, the LED on pin 7 will light up. But because in this example in the circuit, I haven't connected an external LED onto pin 7, I prefer to just use the built-in LED on pin 13 to demonstrate the button presses, and that way we'll be able to also keep the circuit a little bit simpler. Apart from that, this sketch is very simple. We set up the various pins up at the header. We have integer variables for the values that are produced by the joystick, X, Y, and the button. In the setup method, you can see that in the first couple of lines, I turn on the pull-up resistor for the button pin. So again, that simplifies the circuit, so I don't have to connect an external pull-up resistor for the button. This saves us with a couple of jumper wires and a resistor. And also switch the LED pin to an output. And zero begin in line 59. Now in the loop, we use analog read to take readings from the X and Y pins, and digital read to show us the state, or to read the state of the button, whether it's pressed or not. And then we use a bunch of serial prints to show us those values on the serial monitor. Okay, so I'm going to go ahead and upload this sketch. And I've already selected the correct board and port. And the sketch is now uploaded. So let's turn on the serial monitor. And you can see the values are already coming up. So the joystick is right in the middle of its X and Y range, and the button is depressed, and these are the values that you see at that state of the joystick. So I'm going to push now the joystick up, at least in my perspective as I'm looking at it, and you can see that now the X value is maxed out to 1023. I'm going to push it all the way down, and so Y becomes 0. So there's X 1023, Y 0. I'm going to do the same for the X now. So all the way to the left, Y is 1023, and all the way to the right, X is 0. So all the other in-between values, of course, are possible. All right, what about the button? So I'm going to press down on the joystick, and you can see that button is 0, depressed button is 1, 0 and 1, and the LED also turns on when the joystick button is pressed and off when it's depressed. Okay, there you go. So these are pretty simple to use analog sensor. Essentially, it's a simple sensor. It measures position in the 2 axes, and it gives us a button. All right, let's continue in the next lecture, where I'll show you how to use a DC motor with its L293 motor driver. Hi, in this lecture I'll show you how to use the DC motor that is going to be part of this Arduino car alongside the L298 motor controller driver. You can see in this frame here from lecture 900B of Arduino Step-by-Step Getting Serious, I've got the L298N motor controller board and a single DC motor. Eventually, in the car experiments, we'll be connecting two of those DC motors to the controller so that each one can drive a wheel. But to keep things simple, and as we are going through an introduction to DC motors, I wanted to simplify the experiments that I'm about to show you and just have a single DC motor. And everything you'll see is exactly as you see it, duplicated to the second DC motor. More about that in a moment. So if you want to learn more about DC motors in general, not just alongside the L298 driver, but there's a few other drivers that are popular in the makersphere, then you can have a look at section 16 of Arduino Step-by-Step Getting Serious, and there's more content here that you can have a look at. Now, in terms of the sketch that I'll show you a little bit later in this lecture, the original sketch comes out of Arduino Step-by-Step Getting Serious, and you can access it here on the GitHub repository. And I'll be showing you a simplified version of this sketch. This sketch, I've originally set it up for two motors, but I've deleted some of its instructions to make it simpler to learn from and to deal with a single motor as well. There is more documentation that you can find on the Sunfound documentation site, and in particular, I will be using this table here in the practical exercise and experiment that I'll show you in a moment. So you can refer to this if you want more information. And of course, it's always a good idea to take a look at the datasheet of any module that you might be using. And the information that is included here actually comes straight from the datasheet for this particular module. So you can see it right here. So this is a configuration of in 1, in 2, in 3, and in 4, and basically what is the effect on the DC motor depending on what configuration of either ground or 5-volt power you apply to those two inputs. Don't worry too much about this now. This is all going to make sense when we actually work on the experiment in just about a minute from now. All right. So the first thing that we'll do is to not worry about any sketches. So we can totally disignore this. I'm not going to run a sketch on the Arduino. However, I am going to use the Arduino as a power source for the motor driver. And I am simply going to use jumper wires to power up the DC motor, stop it, start it, and then also control its direction. And I'll be referring to this table here to know how to apply power to the motor controller in order to cause a particular reaction from the DC motor. So here is the hardware that we'll be using. This is the hardware. It contains a central integrated circuit up here on the top. You can see it's got a very large heat sink on it to help with heat dissipation because this component can get hot. So that's what this is all about here. There's a couple of capacitors on it as well and a voltage regulator. Now there's 4 screw terminals, pins on either side. So this is out 1, out 2, out 3, and out 4. And this is where you connect your DC motors. In this experiment that I'm about to show you, we'll be using out 1 and out 2 for our DC motor. And notice that there's no indication of which wire on the motor you should plug into which output. Just plug them into any way you want because the motor itself is not polarized, so it doesn't really matter how you plug it in. There's another screw terminal at the bottom with 3 pins. There's 12 volts ground and 5 volts. We'll be connecting the Arduino ground to the middle pin and then the Arduino 5-volt output pin to the 12-volt pin. This is where our motors will be grabbing power from. So just be careful here. I've seen that happening a lot. do not connect the 5 volts from the motor controller to the 5 volt on the Arduino, because this is actually an output where you want to connect the 5 volts from the Arduino in order to power the module and its motors is to the 12 volt terminal. The 12 volt label here indicates that this motor controller can receive up to 12 volts of voltage input. The Arduino, from its 5 volt output pin, provides regulated 5 volt output, and that will be sufficient to drive the 5 volt DC motor that we'll be using. So this is just a label. It doesn't mean that you need to plug in 12 volts in here just because the label says 12 volts. Now here there is the enable pin, and you can see there's a jumper here that permanently drives this pin to high. That means that our motors are always going to be enabled as long as the enable pin is connected to high, and we achieve that with this jumper. And then finally, we've got the in1 and in2 pins. These two pins allow us to control the speed and direction of rotation of the DC motor. And in the first simple example that does not use a sketch, we'll simply be connecting these two pins to either ground or 5 volts, and then we'll be observing the reaction of the DC motor. Now you can also apply PWM signals to these pins. So by applying PWM signals on one of the two inputs, either one is okay, you will be able to control the speed of the motor, and then you'll be able to control the direction of the motor by manipulating the voltage on the second input. For this experiment, we'll leave in3 and in4 unconnected. Okay, let's continue at my workbench and have a look at the first experiment. So I've already made the connections here. I've done the wiring to save us a little bit of time. So I'm going to go through the wiring first and then go ahead with our experiment. Now for power, beginning with that, I'm using my 9 volt battery. I have not connected the Arduino to my computer, and the Arduino is running a sketch on it, but I'm not going to be connecting any of the L298 motor drivers pins to any of the Arduino output pins. I'm just going to take power out of the Arduino, and that's about it. So I'm going to connect the 9 volt battery to the Arduino through its bottle connector here, like that. All right, next I've got the motor driver itself. As you can see, I have made the connections first to the DC motor itself. Now don't worry about how you connect the DC motor wires to the motor driver. It doesn't really matter whether the black wire goes to out 2 or out 1 or vice versa. Just connect them in any way that you like. Now moving up to the top side, we've got the 12 volt, which I'm using as power input, and you can see that that is connected to the red rail on my breadboard. The red rail on the breadboard, via this red wire, I've connected it to the 5 volt pin on the Arduino, like that. For the ground, this is the middle screw terminal that goes to the blue rail on the breadboard, and via this black wire, I'm taking the ground level from the Arduino. So in this case, I'm using the breadboard so that I can easily apply ground or 5 volt level to the in1 and in2, since I only have one 5 volt pin on the Arduino. All right, now I have used a yellow and a blue jumper wire to connect in1 and in2 to, at this point, ground. So I've got both of the in1 and in2 inputs of the motor driver connected to the same level. And I'm just going to show you the table of operations that I got from SunFounder. And you can see right here, if in1 and in2 are 0, 0 or 1, 1, then the motor is not working. Essentially, it's going to stop working, and let's call it a break. You can still move the motor, so it's not like it's going to be unstoppable, but yeah, there is there's quite a bit of torque here because of the gears inside the gearbox. So it makes it a bit harder to turn. But if I putting the wheel on and turn it, you see that there's no actual brake in there. It's just there's no power applied to it. Okay. So when I plug in my 9-volt battery to the Arduino, because both in1 and in2 are connected to the same rail, in this case it's the blue ground, I could even have plugged both of them onto the 5-volt. They are on the same level, so the motor will not work. But if I switch any of those two wires to its opposite level, then you'll see that I'll have movement, and that's what we'll experience in a moment. All right, that's it. I'm going to apply power to the Arduino, and notice that I've got just a little sticky note here so we can easily see the rotation. So I'm going to take one of those two wires, it doesn't matter which one it is, and we're going to plug the yellow wire, which is in 1, to ground. And just by removing it, actually, that's enough. But I'll put it to ground. And you can see that the motor is now spinning clockwise. So let's try to get it to spin the opposite way. I'm going to move the blue wire and put it to ground, so it's all stopped, and then switch the yellow wire to 5 volts. And now the motor is spinning counterclockwise. I can't control the speed yet, because to control the speed, I need to be able to send PWM signals to the motor controller, and for that I need to use the Arduino and run a sketch, compatible sketch on it. So now that we know how to at least control the direction at full speed each time, we are going to continue with the next experiment and upload the motor controller sketch onto the Arduino. And I'm going to have to do a bit of rewiring so that we can now use PWM signals to control the speed of the motor. So now that you know how to control the direction of spin of the DC motor, depending on the voltage level that you apply to pins in 1 and in 2, we are going to have a look at how you can control the speed. And I mentioned earlier that to control the speed, you need to apply PWM signals. So for that, we're going to use the Arduino, and here is a simple sketch. The original sketch comes from Arduino Step-by-Step Getting Serious. Looks like this here. There's a bunch of lectures here, and in its original version, this sketch controlled 2 motors. I've deleted several lines, so everywhere you see speed 2, etc. And there's a couple up here. I've deleted those lines. We don't need them for an experiment that only includes a single DC motor. But remember, you can apply the exact same code on a second motor that is connected to output 3 and output 4, and then use in 3 and in 4 in the motor controller to control that second DC motor. All right, so what is happening here in this sketch? First, I set up 2 pins on the Arduino. One is going to be digital pin 5, and this is what controls the speed. And you can use any other digital output pin as long as it's PWM capable. And as you can see, pin number 5 is PWM capable. For the directional pin, you can use any pin on the Arduino. This pin is just going to switch from 0 to 1 or from high to low and control the speed of rotation. So we also have here a variable that keeps track of the direction, whether the direction is clockwise or anti-clockwise. You can see down here that I'm just flipping this Boolean variable to its opposite when I want to switch direction. In setup, I set both pins as outputs, and then inside the loop, first I write the direction that I want to direction 1. Basically, this is pin 4, either turn it high or low, and that will control the direction. And then I use analog write on pin 5 to write a PWM value, and that will set the speed. And then I'll let the motor run for a second on speed 205, then change the speed to 100, let it run for another second, and then 150, let it run for another second, and then switch direction, and then write 0 to analog write, which essentially will stop the rotation. I'm just going to add another delay for 1 second here so that we can actually notice that the rotation has stopped. All right, so that's all. I'm going to upload the sketch. I should provide the upload port for the Arduino and try again. Okay. So counterclockwise, you can see the different speeds. And clockwise. There you go. Now that the sketch is uploaded, I can actually disconnect the Arduino from my computer. I can try to do that with a single hand. Just put it down for a second. And as you can see, the rotational speed is controlled via the PWM pin 5, which in this case I have connected to in 1. You can actually switch this around. I will take power off to show you. So I'm going to flip around these 2 pins. So I'm going to flip or switch in 1 to Arduino pin 4, and then in 2 to Arduino pin 5, and essentially switch which one of the inputs control direction and speed. And as you'll see, when I power up again, the effect on the motor is the exact same. It's just that now the direction and the speed has flipped. Meaning that what signal configuration earlier would cause a clockwise rotation of a particular speed now causes a counterclockwise rotation of the same speed. Okay, let's continue with the infrared sensor in the next lecture.